of sections out of the book today. The first one is 10.3. We're just going to do it really quickly. It's solving quadratic equations by graphing. Well, let's just think about how we solved these in Chapter 9. Chapter 9 was about factoring polynomials, was it not? So if this was a Chapter 9 problem and it said we were just solving it, we would solve it by factoring, which would mean it's a trinomial equal to 0, so we would make a what? A table. And we would say we need two numbers that multiply to get positive 5, but add to get negative 6. And what two numbers would have done that for us? That don't multiply.
I think negative 5 and negative 1.
Yes. Yes. And then we would have said, okay, that's a short way trinomial, so we would have said x minus 5 times x minus 1 equals 0, right? And then we would have set those both equal to 0. And we would solve them. So we would add 5 and x equals positive 5. And then we would add 1 and x equals positive 1. And those were our two solutions. But now that we're in Chapter 10, we have learned that this is a quadratic equation. And what is the graph of a quadratic equation? It's called a what? Parabola. Right? So the graph of a quadratic is called a parabola. So now that we know that that's quadratic because it has the x squared in it as the highest exponent, we know it's going to be a parabola. We can solve this equation by graphing. And the way we do that is we graph that polynomial, that quadratic, and we're going to see where that parabola crosses the x-axis. That's why your solutions to a quadratic are sometimes called x-intercepts. This means the same thing. So the solutions to a quadratic is the same thing as finding the x-intercepts of the parabola. So I'm going to show you how to graph a parabola in your calculator. First of all, you want to make sure your equation is equal to 0. And ours is to start with, right? Then you're going to get out your graphing calculator. And you're going to hit the button that says y equals. And it's to the left-hand side right under the screen. Y equals. Well, I'm going to turn mine on. Hit y equals. And your screen should look like this. None of the words that say plot up at the top should be darkened. It should look like this. Nothing should be darkened. There shouldn't be anything else entered in it. It should be blank except for that cursor flashing. And what we're going to do is we're going to type in that original quadratic equation without putting the equal 0 in. So the X you're going to use is right next to the green alpha button. Well, if you have a newer calculator, it might be a different color. But right next to the alpha button, there is a button that has a bunch of variables there. The first one being X. So hit the X. It gives you an X there. For the square, there is a square button. See diagonal from the 7, it says x squared. Y'all see that? Diagonal from the 7, it says x squared. So put that and it gives you the square. And then you're going to hit minus. You're not going to hit the white negative sign. You're going to hit the blue minus button. Okay? So if you hit the little negative, it won't work. So hit the big blue minus button. And then you're going to hit 6. Then you're going to hit the same x up there again. And then you're going to hit plus. And then you're going to hit 5. So you're just typing in that quadratic equation without the 0. Everybody look at mine when you get finished typing it and make sure yours looks like mine. I'll load it. Okay? So now we're going to graph this quadratic, which we know is going to be a parabola. So to graph it, over here on the right-hand side under the screen, there's the graph button. I want you to hit graph and watch your calculator graph your parabola. Raise your hand if you don't have my parabola on your screen. Well, that's a miracle. Good job. Everybody has a parabola. You don't? Hit graph. Now you have a parabola? Does everybody have a parabola? You don't have a parabola? Yeah, your plot's turned on. Me either. Raise your hand if yours is not centered like mine. Raise your hand if you don't have the X and Y axis that it's centered. Is everybody straight? Yours is not straight. My calculator's. You've been touching a bunch of buttons. There you go. If it's not straight, then I can fix that. You didn't type it wrong. X squared minus 6. There's 6. There's 6. I got you. Does everybody have the parabola now? If you don't, you gotta let me know because you're not gonna know how to do this. All right. So look at your graph and look at where the x-intercepts are at. Where are the x-intercepts at? I believe it's 1 and 5. Right? What did I get when I solved by factoring? 1 and 5. So solving by graphing is another way of solving a quadratic equation. We're also going to learn a few other ways, such as complete the square and quadratic formula. And then you'll learn a few other ways when you get to Algebra 2. Thank you, ma'am. You need a graphing calculator out today. All right. So, let's go to our next equation. So from here on out on this lesson, we're just going to do the calculator and write down our x-intercepts. Okay? So the first thing I need to do on this problem right here is get it equal to 0. It's not equal to 0 right now. It's equal to 3. So how do I get this equal to 0? Subtract 3 and put it over here where it goes. Now make sure that your polynomial is in decreasing order. X squared minus 2x minus 3, and then you put equals 0. So you got to do whatever you need to do, put it wherever you need to put it to get it in order from x squared to x to constant. Okay? And then after you get it equal to 0, you turn on your calculator, go to y equals. Okay? Hit clear. Get it back to a blank slate. Sorry, mine's over too high. All right, so then you're going to type in x squared. Where's the x again? Right beside the green button. So hit x. Where's the square? Diagonal to the 7, right here. And then hit the big minus sign, not the little negative, but the big minus. Minus 2x, minus 3. And then after you hit your 3, you can hit graph. And you should see a parabola. Raise your hand if you do not see a parabola. Everybody good with the parabola? All right, so now we just got to look to find our 2 x-intercepts. What are they? Where am I crossing the x-axis at? -1 and +3. So you just go to your problem and you say x equals -1 and x equals 3. Those are your two answers. Sound good? I know. We should like this. You're going to have questions like this on your quiz tomorrow. You're welcome. Okay? All right. Let's do one or two. We haven't done a negative one yet. Let's do this one. All right. So what's the first thing we have to do to this equation? Yes. So we subtract the 1 on both sides. So that is -x squared plus 2x minus 1 equals 0. All right, so then you're ready to go to your calculator. The y equals button over here. Clear it out. This time, you have to hit the little negative. So if the leading coefficient is negative, you use the little negative. If it's a minus, you use the big minus. But if the leading coefficient is negative, use the little negative down there by the inner sign. So negative x squared plus 2x. Now, y'all, before I graph this, what does that negative do in front of my x squared? Yeah, you should have an upside down U-shaped parabola. All right, so after you get that, hit graph. And you should see an upside down U-shaped parabola. Negative x plus 2x. Now, how many times is this graph touching the x-axis? It's only touching it one time because the vertex is where it's touching the x-axis at. Y'all see that? So this is a case where you would only have one solution. Okay? So if your vertex touches your x-axis, you only have one solution. So where am I touching it at? At 1. So we would just say x equals 1. So that would be like this. This is the perfect square trinomial, right? What multiplies to get negative 1 adds to get positive 2. Well, first we got to factor out the negative, and it would be negative 1 and negative 1, and set them equal to 0, you get x equals positive 1. So that's why you only have one solution, is because it's a perfect square trinomial. All right. What do we have to do first on this one? How do I do that? Good. Subtract 4x on both sides. And we got to put that one in the middle, don't we? That's the b term. So make sure you put them in decreasing order. X squared minus 4x plus 7 equals 0. So make sure when you rearrange, you put it in decreasing order by their powers. And then you go to y equals. Clear it out. Y'all know where the clear button is. It's below the arrows. Did y'all find that? Clear button's below the arrows. I didn't tell y'all that. So then you do x squared minus 4x plus 7. And then look up and make sure yours looks like mine. And then go ahead and hit graph. And does your parabola look like mine? What's up with that? That is never, ever, ever crossing the x-axis, is it? No, my vertex is up here in quadrant 1, but it's never ever touching the x-axis. Okay? So, because my range of my function looks like y is going to be greater than 3, greater than or equal to 3. It's never crossing the x-axis. So, do y'all know what we write for our solutions then? No solution. Because when you're finding a solution to a quadratic equation, you're looking for x-intercepts. And if it never has an x-intercept, then you're going to have no solution. Does that make sense? So y'all don't have to write this down. But this is just 3 scenarios. Okay? A lot of times, your parabolas will touch the graph in 2 places. And then you'll have how many solutions? 2. Or it could be upside down and cross in 2 places and you have 2 solutions. Right? Or it could be a situation where only the vertex touches the x-axis. So then you would have 1 solution. Or it could be upside down like the one we saw. And it's only touching 1 place. And you have 1 solution. Or it never touches the x-axis. And you have no solution. So you could get 2 solutions, 1 solution, or no solution for these. Okay? And that's all we're going to do on section 10.3. So y'all can put your graphing calculators away now because we're going to now graph some more by hand using something called vertex form. So you do need graph paper for these. And this is not a whole section in the book. It comes after section 10.5. So I've just named this section 10.5b, second part of 10.5. It's after section, between section 10.5 and 10.6 in your book. And this is vertex form of a quadratic equation. I like vertex form because it's really easy to find a vertex if you have an equation in vertex form. It makes, you know what we did yesterday when we found the axis of symmetry and then plugged that in to get the vertex? Well, vertex form kind of skips those steps for us, okay? Because we can look at this equation and tell you right off the bat what the vertex is. You actually need to memorize this form. It's a parentheses x minus h squared plus k. Your a is the same as any a term for a regular quadratic. So standard form is ax squared plus bx plus c. That's what we've been doing everything in since yesterday. So the a is the same. It's the leading coefficient. So if a is positive, do you have a U shape or an upside down U shape? U shape, and the vertex is a what? Maximum or minimum? Minimum. If a is positive, your vertex is a minimum. If a is negative, you have what kind of parabola? Upside down, and the vertex is a maximum. Okay, so a is still doing what a did earlier. The only thing is this h and k business. Okay? The h is in the parentheses with the x. Okay? So what you're going to do is whatever this h is, you're going to swap your sign, and that will be your x value. Whatever the h is, you swap its sign, and that's your x value for your point, for your vertex. She's saying the same words I am today. Your k is the y value of the vertex. So your k equals the y. To get your x, you take this number right here and change its sign. Change it, keep it. K for keep. Right? Yes. This will be your x. This will be your y. Okay? So here's an example right here. We're going to graph this parabola. All right? But first we have to pick out the vertex from the formula. Okay? So this is my h. This is my k. It says swap sign for x. That's what it says. Sorry. So my vertex, to get that ordered pair, I'm going to swap the sign of my h to get the x value. So what's the opposite of 1? -1. And k, you keep it to get your y. So that is -1. It's easy to get the vertex. You swap the sign, that's your x. Keep this, it's your y. And they go in order, x then y. And plus the x is with the x in parentheses. Does that make sense? But you swap the sign, and then you keep the second one for your y. So now that you know the vertex, you can tell what the axis of symmetry is, can't you? What's the axis of symmetry? X equals -1. Right. The x value of the vertex is your axis of symmetry as a vertical line. Right? Does that make sense? So if we know those two things, we can start our graph. So graph you a x and y axis, please. Mine's a little crooked. And then graph your axis of symmetry and your vertex just like you did yesterday. So for x equals -1, we're going to go to -1 on the x-axis and draw a dotted line. And then we graph the point -1, -1, which better be on our axis of symmetry. And from here on out, it's just like yesterday. Okay, we pick another x value close to our axis of symmetry, plug in that x value, get the y, go the same number of spaces over to get the second point. So what do y'all want to let x equal? Me too. So let x equal 0. Now y is going to equal parentheses 0 plus 1 squared minus 1. Order of operations. What do you think we're going to have to do first to simplify this according to the order of operations? Inside the parentheses, we add 0 plus 1 and get what? So this is going to be 1 squared minus 1. What's 1 squared? 1 minus 1 equals 0. So 0, 0 is a point on my parabola. And how many spaces away is that from my axis of symmetry? So I go one space in the other direction, graph another point on the x-axis, and then draw your parabola. Put arrows on it. Is that vertex a maximum or a minimum? Try again. It's a minimum. It's the lowest point. But that's it. Vertex form, you just have to look at the formula to write down your vertex, and then from there, get your x to be the axis of symmetry, and then you do everything just like yesterday after that. Okay? I like vertex form personally because it's a lot shorter because you don't have to find the axis of symmetry and the vertex by plugging it in. You can just look at it and tell the vertex. So, let's see if we can do that for number 2. This is in vertex form, so we should be able to look at it and tell what the vertex is. How do we get the x value of the vertex? The number in parentheses, we change its sign. So my x value is going to be what? -2. How do we get the y value? You keep the k, right? So 3 is going to be our y value. So any questions about how we get the x or the vertex, the x and the y of the vertex? Change it, keep it. In that order. Change it, keep it. All right. So my axis of symmetry is going to be x equals what number? Yeah, the x value of the vertex, -2. So now you're ready to start graphing it. Is this going to be a parabola or an upside down parabola? U-shape or upside down U-shape? How do you know? Because A is a -1, isn't it? All right, good job. So -2, 3 will be the maximum, which means it will be the highest point on the parabola. So you need a vertical line at x equals -2. And then go left 2, up 3, and there's your vertex. So that's going to be the highest point on your parabola. What do y'all want to pick for your x to graph your second point? I like 0 too. So x equals 0. Now that's, y'all, when you have a negative up against parentheses, it makes life so much easier if you make it a -1. Some people get confused when it's just a negative, not a number. They forget they're multiplying times -1. So order of operations, I'm going to add it, then square it, then multiply it, then add it, right? Parentheses, square, multiply, then add. So what's 0 plus 2? So that's -1 times 2 squared. What's 2 squared? So -1 times 4 plus 3, which makes -4 plus 3, which makes what? -1. So 0, -1 is a point on my parabola. It's right down here. How many spaces is that point away from my axis of symmetry? 2. So I go 2 spaces in the other direction and put another point for my parabola, because they have to be symmetric on both sides. Draw an upside down parabola. And there it is. So this isn't so bad, is it? Y'all think this is easier than yesterday? I think it is. Once you get the hang of picking out that vertex, it's like, oh yeah, we like this better. Okay. All right, I want somebody to tell me what the vertex is. 1, -2. Change it, keep it. Y'all ready? Y'all understand that? Change it, keep it. What do you do with the 2 in front, though? Nothing. You don't do nothing until you start plugging in numbers. All right, so what is our axis of symmetry? X equals 1. So go ahead and graph those 2. Is this vertex going to be a maximum or a minimum? Minimum, because we're going to have a regular U shape because there's a positive A term. So go to +1, make my vertical line. And my vertex better be on that line. Write 1 down 2. It is. What do we want to use for our X to get our second point? 0. So let X equal 0. So that's going to be 2 times 0 minus 1 squared minus 2. And then I'm going to do my order of operations in there. So parentheses first. What's 0 minus 1? -1 squared minus 2. What's -1 squared? +1. 1 times 2 is what? Minus 2 is what? 0. So the origin is a point on my graph. And then I'm how many spaces away? 1. And so I go 1 space the other direction and make a U. Now this is narrow because that 2 is my A term right there in front, which remember numbers greater than 1 made it more narrow. So there we go. And the vertex is a minimum. So any questions about graphing with vertex form? All right, the last thing I want to show you in this section is how to find a vertex and write an equation in vertex form. So we're not going to graph this one. They gave me standard form. Remember, standard form is y equals ax squared plus bx plus c. And we're going to change from standard form into vertex form. We're not going to graph this one. Okay? So we're changing from standard form to vertex form. So, to write it in vertex form, we need a vertex, don't we? How did we get a vertex yesterday when all of our equations were in standard form? We had standard form yesterday. How did we get a vertex? No. You got to get axis of symmetry. Then what do you do after you get your axis of symmetry? Plug it in for all your x's so you can get your y. So that's what we're going to do. So first you got to do axis of symmetry. How do you get axis of symmetry? What is the formula? Very good. X equals negative b over 2a. And we say x equals because it's a vertical line. So negative, what's our b? Over 2 times what's our a? -2, so is this a U shape or an upside down U shape parabola? Upside down. So this is -4 over -4, which is what? So x equals 1 is our AOS. So how do I get the y value so I can have my vertex? Plug 1 in for all the x's. So -2 times 1 squared. 4 times 1 plus 1. What's 1 squared? What's 1 times -2? And then 4 times 1 is 4 plus 1. So that's 2 plus 1, which equals 3. All right, so what's my vertex then? 1, 3. So now that I know my vertex, I can put it in vertex form. Remember, vertex form is y equals a times x minus h squared plus k. So all I have to plug in is my a, my h, and my k. Remember, on this one, we got to change the sign, though. Right? They're opposite signs. So what was my a term for my standard form? So -2 will still be my a term. And then x, and then I change my sign of my x value of the vertex. So do I put +1 or -1 in parentheses? What's the opposite of 1? Yeah. So I say -1 squared, and then keep the k is your y, the same thing as your y. So I put what at the end? +3. There's my vertex form. So to go from standard form to vertex form, you find your vertex. Your a term is the same as your a term. You swap the signs on your x to get the h term, and your k term is exactly the same thing as your y. Y'all need to see one more of those? Okay. We'll do one more of these. All right, they're giving me this equation in standard form. Y'all tell me, is the vertex going to be a maximum or a minimum for this equation? A minimum. This parabola is a U shape. All right. To write it in vertex form, I need a vertex. How do I get a vertex from standard form? You find the axis of symmetry first. So my AOS, what's the formula for that? X equals -b over 2a. So negative, what's my b? Over 2 times what's my a? 4. Then I simplify. Oops, sorry. -8 divided by 8 equals what? -1. So x equals -1. The axis of symmetry. Then what do I do with that? How do I get the y value? You plug in -1 for all my x's. So 4 times -1 squared plus 8 times -1. -1 squared is +1. Do y'all agree? And 4 times 1 is 4. 8 times -1 is -8 plus 10. 4 minus 8 is what? -4 plus 10 is what? 6. So my vertex is going to be the point -1, 6. So now we're ready to put that in vertex form. What does vertex form look like? Y equals what? With all the variables? Plus k. So I'm going to say y equals, what's my a? Same as it is in standard, it's 4. Parentheses, how do I get my h term? Change the sign of your x, so that's going to be x plus 1 parentheses squared. And what goes for k? So it's positive, and I keep it positive, plus 6. So there we are in vertex form now. Same equation. This one's in standard form. This one's in vertex form. You'll get the same parabola. All right, we're going to stop with that for a second. So any questions about vertex form? It's just another simple way to graph a parabola, another way to rewrite it so it's easier to graph. And that's about all. So that is the last thing on our quiz for tomorrow. So your quiz for tomorrow will have making parabolas with tables, and then making parabolas where you have to find the axis of symmetry and the vertex. So everything that was on that worksheet you did yesterday, okay? And then also graphing with a calculator and telling me the x-intercepts, and graphing with vertex form, okay? That's all of the quiz material. And since we have time and not very many days left, I'm going to go ahead and start completing the square today, okay? So there is no graphing in the complete the square lesson. And this is not on your quiz tomorrow. We're going to practice it some more tomorrow. It is not on your quiz. Okay, so completing the square is another way to solve a quadratic. So far we solved quadratic equations in Chapter 9 by factoring. And then just a moment ago, we solved quadratic equations by graphing the parabola and looking for the x-intercepts. Okay? So another method of solving a quadratic equation is by doing something called complete the square. Complete the square. So, to complete the square, we don't want to be equal to 0. Okay? I know in the last few sections, when we have to solve a quadratic, you've got to be equal to 0. Same thing with quadratic formula, will have to be equal to 0. So complete the square is kind of like the oddball, where you don't want to be equal to 0. You actually want to be equal to a C term. Remember, a C term is a constant. It's a term that does not have a variable. So you're going to take your term that does not have a variable and put it on the other side of the equal sign. So you want everything on the left-hand side to have x's. Now, what you're going to do is you're going to put another C term on this side that makes a square polynomial. That's what complete the square does. It makes you have a polynomial square. So the way we get to have a perfect square polynomial over here is by these steps over here. You're going to half the b term. What's the b term? What do I mean by b term? The term with a what? Just the x, not the x squared. The middle term if we were writing it in standard form. So you're going to take the b term, half that number, and then square that number, and then put that number on both sides of the equal sign. Because if you got an equation, what you do to one side is going to be the same. You got to do the same to both sides. So what's half of 6? So here's my b term. That's my term I'm looking for. What's half of 6? 3. Square 3, and what do you get? 9. So you're going to add a 9 to both sides. So that's going to make us have the polynomial x squared plus 6x plus 9 equals 16. Y'all see that? Then you're going to kind of factor in your head. What multiplies to get 9 and adds to get 6? 3 and 3. So that's our magic number is half the b term. That's our magic number. Okay? So our magic number is 3. So isn't this, when I factor this trinomial over here, isn't it x plus 3 squared? X plus 3 times x plus 3 makes that. So leave that equal to 16. So what you want to get it to is a perfect square binomial over here after you factor. That's why you have to be term squared to add it both sides. So this side can be a squared binomial. Now, in mathematics, we deal with inverse operations to solve equations, right? What's the inverse of adding? What's the inverse of dividing? So what do you think is the inverse of squaring something? Taking a square root. Very good. So to get rid of the square so we can solve for x, we're going to take the square root of both sides. And a square root will cancel each other out. So then it's x plus 3 equals. Now, y'all, the square root of 16 could be positive 4 or it could be negative 4, right? Because negative 4 squared equals 16 and positive 4 squared equals 16. So you got to put plus or minus. That's what that plus and minus sign means. We got to consider it being positive 4 and negative 4. Could be a positive 4, could be a negative 4. No, the square root of 16 equals 4, so you don't put the radical there. We're going to simplify radicals next chapter. That'll be a little bit clearer. So then what you do to get the x by itself is you subtract 3. And I'm just going to stick it in front. X equals negative 3 plus 4. And then you just break that into the two problems it is. Negative 3 plus 4. And x equals negative 3 minus 4. So then you break up your plus and minus. Negative 3 plus 4, negative 3 minus 4. And then you simplify them. So over here, x is going to equal 1. Over here, x is going to equal negative 7. So if I were to graph my equation at the very beginning and get it equal to 0 and graph it in my calculator, I should be crossing the x-axis at 1 and negative 7. So that would be a good way to check that. Even though we're not solving this by graphing, you could still check it by graphing. Does that make sense? So complete the square. It's not easy. It takes longer for me to explain it than it will to actually do it once we get the hang of it. Half the b term, square it, add it to both sides. Half the b, square it, add it to both sides. Then you factor. Then you get it equal to an x squared. Then you take the square root of both sides, and you got to consider plus and minus. Because most of the time on a quadratic, we will have two solutions. All right. Notice that I left a space right here so I can add my number. I kind of leave you a space there after the x. We'll do a few more of these, and then we'll call it a quit for the day. All right, so we don't want it equal to 0. We want it equal to a number over there. We don't have an x with it, so it's already set up the way we want it. So then we're ready to half the b term, square it, and add it to both sides. So what's half of negative 16? Negative 8. What's negative 8 squared? 64. So I'm going to add 64 to both sides. Because it's an equation. What you do to one side, you got to do the other side. All right, so then we're going to factor this trinomial right here. What multiply to get 64 and add to get negative 16? Negative 8, negative 8. Now, that's our magic number. It was half the b term, right? So if you remember the magic number, you don't have to factor it. You remember it's x minus 8, so this is going to be x minus 8 squared, right? Because x minus 8 times x minus 8 multiplied to get us x squared plus or minus 16x plus 64. And then you add those two numbers over there because they're like terms, and what do you get? 49. Then we want to get rid of the square to solve for x. And what mathematically gets rid of a square? Take the square root of both sides, because what you do to one side, you got to do the other. Squares and square roots cancel each other out. So that's x minus 8 equals plus and minus 7. So make sure you do plus and minus because we need two answers out of this. Then how do we get rid of the 8? Add 8 to both sides. So x equals 8 plus and minus 7. I'm going to come over here so I have room. So x is going to equal 8 plus 7, and x is going to equal 8 minus 7. What's 8 plus 7? X equals 15. And what's x minus 8 minus 7? 1. So there's my two solutions right there. So if you were to graph this in your calculator, it might not show it this one on the screen because your calculators only show you a 10 by 10. You'd have to trace and do a lot of work to do it. So complete the square is actually probably a better way to do this one. This is really not bad when you get the hang of it. Let's do C. Let me see how many left. I don't think there's many left anyway. There's a U try. We'll do a U try after this one, and then we'll call it a day. All right, this one's really not set up yet correctly for complete the square, is it? No. What do we think we do to get it set up correctly? Very good. So we need to move the constant term to the other side. So that's going to be x squared minus 2x. Skip a space because you got to add them. And 0 plus 4 is 4. So leave you a little space there because you got to have to b squared and then add that number to both sides. So b is negative 2. What's half of negative 2? Negative 1. What's negative 1 squared? Positive 1. So you're going to add positive 1 to both sides. So the magic number we said was negative 1, right? So this is x minus 1 squared. 5. Aw, decimals. Yuck. Square root both sides. Cancel, cancel. X minus 1 equals plus or minus the square root of 5. Go ahead and give me a couple of decimals. You want me to take the square root in the calculator? Second x squared. The x squared is diagonal from the 7. I'll show you on mine. You hit 7. Let me turn mine on. Second x squared 5. Now, next chapter, this will be a no-no. We will not be typing in square roots to get decimals. I'm going to say 2.24. Will that work? And I'm going to change my equals to a squiggle because I don't like that one. So x is going to be approximately 1 plus and minus 2.24, right? Then we break up our plus and minus. X is approximately 1 plus 2.24. And x is approximately 1 minus 2.24. So what's 1 plus 2.24? 3.24. And what's 1 minus 2.24? So if I were to graph that one originally, it's already equal to 0. You can kind of see if it's crossing between 3 and 4 and negative 2 and negative 1. Okay, so that is complete the square. I don't think I'm going to give you any homework on that one tonight, but I do want you to try one on your own. Y'all try that one. You should not get a decimal on this one. It's already set up. No decimals. All right, y'all tell me how to do it. What'd you do first? It's already equal to what it's supposed to be equal to, so what did you have to do? Half the b term, square it, and add it to both sides. So what's half of b? What's negative 1 squared? Positive 1, so you add a 1 to both sides. Does everybody do that? And then the magic number was negative 1, right? So you had x minus 1 squared, right? Equals 4. And then what did you do to both sides? Square root both sides. So then you cancel. X minus 1 equals plus or minus 2. And then what did you do to both sides? Get the x by itself, add 1. So you had x equals 1 plus and minus 2. So x equaled 1 plus 2, and x equaled 1 minus 2. And what's 1 plus 2? And what's 1 minus 2? Raise your hand if you got 3 and negative 1. Did anybody pop it in the graph and check it? Nobody did, but you can. If you're on your own, you can do that. So we're going to save practice on this section for tomorrow after your quiz. Does that sound good? Since I've taken up most of our homework time today already. So that is the end of all 3 of today's lessons. Have a good day.